Alright everybody, welcome back for what should be the last video of the class. Section 10.15, video number 2. We're talking about representing functions as power series. We're going to pick up right where we left off. We had done examples 1, 2, and 3 in the previous video, and in this video we're going to do examples starting with number 4. And hopefully I will not be so long-winded that I don't get through all of these examples in the next 14 minutes and 30 seconds. All right, so here we go. Example number 4. Let f of x be 2x minus x squared, blah, 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 blah. Part A. Write the first 3 terms and the general term of the series for f prime of x. Well, since we have f of x and we want the first 3 terms and the general term, all we're going to do is take f of x and we're going to go term by term and take the derivative, since we're looking for f prime, of the first 3 terms, which are going to give us our first 3 terms, and then we're also going to take the derivative of the general term. And then we might need to clean that up in the end, but let's see what happens. So we've got f prime of x. The derivative of 2x is 2, the derivative of x squared is 2x, and the derivative of 4x cubed over 3 factorial ends up being 4x squared, 4x squared over 2 factorial, because the 3 that I get when I take the derivative cancels out with the 3 from here. I probably should have just done 12x squared over 3 factorial so that it didn't confuse me. Notice how I got confused there for a second as far as what was going on. I can always simplify those coefficients later. All right, so there's my first 3 terms. My general term, the alternator is going to stay there. All right, and the derivative of this term is going to be, let's see, all this constant stays there for now, and then the derivative of x to the n is going to be n times x to the n minus 1. All right, so now let's clean this up a little bit. We've got f prime of x equals 2 minus 2x plus 2x squared, it looks like, 12 over 6. And then here, this n can cancel out with an n from n factorial here, and this turns into negative 1 to the n plus 1 times n plus 1 times x to the n minus 1 all over n minus 1 factorial. Okay, now realize, take a look at what we've got. If we want this to be the 0th term, all of our n's in this expression are off 1. If we put 0 in here, we've got x to the negative 1, and we're taking a negative factorial. So what I'm going to want to do in this, to make sure that I have this laid out the way that I want it, is I'm going to actually address the general term so that it matches that this first term that we see here is the 0th term. In order to have that happen, we need x to the 0 power in this one when this is 0. So we need to adjust this so that it's x to the n in that general term. And so in order to do that, in order to turn n minus 1 into n, we need to add 1 to it. And what we're going to do is we're going to add 1. I'm going to give myself a little bit of room here. We're going to add 1 to all of the n expressions in this general term. Sorry about the gap there. I ran myself out of space. But we're going to add 1 to each of these n expressions. So this is going to be negative 1 to the n plus 2 times n plus 2 times x to the n all over n factorial. And so the 0th term works out as even 2 times x to the 0 over 1, which gives us the 2, and that matches all the terms there. And so there is our first 3 terms and our general term. Well, I'm already well on the way to being too long-winded here and not getting through all the examples. All right, let k of x be the integral from 0 to x of f of t dt. Again, first 3 terms and the general term. So now we want to integrate And so k of x is going to be equal to the integral from 0 to x of f of t dt. So we're just going to integrate term by term. The integral of 2x is going to be x squared. The integral of x squared is going to be x cubed over 3. The integral of this one is going to be x to the 4th over 3 factorial. And my general term, all the constant stuff stays the same, but this, the x to the n, I go up by a power, and I divide by that power. All right, now cleaning up my general term, these two things cancel each other out. And if we want this to be the 0th term, then this needs to be 2 when n is 0. So we need to adjust by adding 1 to all of the remaining pieces in this general term, all of those n factors of the general term. And so this is going to be -1 to the n plus 2 times x to the n plus 2 all over n plus 1 factorial. And there we go. There is my first 3 terms and my general term. No matter what, when I'm doing these, I always like to justify my general term so that the first term I see in my polynomial is the 0th term. And so I like to square those off. Some people aren't as meticulous about that as I am. And that's okay. But, to each their own. All right. Example 5. Use the Maclaurin series for cosine of x to construct a series for x cosine of x squared. All right, so cosine of x, the series for cosine of x is 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, etc. Up to the general term, which is -1 to the n, x to the 2n, all over 2n factorial. And so cosine of x squared is going to be a substitution move here. We're going to replace all of the x's with x squareds. Well, that should be an 8. And so we're going to replace this with an x squared. So that's going to be x to the 4n. When we do that. And then to get to x cosine of x squared, we're just going to take the series for cosine of x squared, and we're going to multiply every term by x. And that makes this our series. And there's our series for x cosine of x squared. Example 6. Find a power series representation for the function f of x equals 2x squared e to the x cubed. Again, we start with a known Maclaurin series. We know that e to the x is 1 plus x squared, plus x squared over 2 factorial, plus x cubed over 3 factorial, etc., etc. And the general term is x to the n over n factorial. So now we'll write a series for e to the x cubed, where we're going to replace all of these x's by x cubed. I got rid of all my factorials there in my first 4 terms. And then, to turn this into 2x squared e to the x cubed, we're just multiplying the series for e to the x cubed by 2x squared. This becomes 2x squared, 2x to the 5th, 2x to the 8th over 2, which is just x to the 8th, 2x to the 11th over 6, which is just going to be x to the 11th over 3, and then 2 times x to the 3n plus 2, all over n factorial. And no adjustment needed on my general term here because it matches my specific term already. One last one. Power series for 3x squared over the quantity 1 minus x cubed quantity squared. There's a couple of different ways we could handle this one. It's important to me, I look at this and I'm like, okay, now, what do I know that's related to this function that I know a series for? And I look at the denominator and I've got, 1 minus something raised to a power. Well, I could, without great difficulty, write a series for 1 over 1 minus x to the third by using the series for 1 over 1 minus x. All right. Now realize this, if I take the derivative of this, what do I get? I get this whole expression right here. So this is the derivative of 1 over 1 minus x cubed, and we've got to look for those relationships. So I start with the series for 1 over 1 minus x, which is 1 plus x squared plus x cubed plus x to the fourth plus x to the n. And then I use that to write the series for 1 over 1 minus x cubed. That's going to be 1 plus x cubed plus x to the sixth plus x to the ninth plus x to the 12th, all the way up to x to the 3n. And then to get the series for the function that I started with, that's the derivative of this. So I'm going to go ahead and just take the derivative term by term. This is going to be 3x squared plus 6x to the fifth plus 9x to the 8th plus 12x to the 11th plus 3n times x to the 3n minus 1. All right, now my general term doesn't jive out, so that this is to the 0th power. So I'm going to replace everything that's represented by n here with n plus 1 to shift that general term so that this is the 0th term right here. And so I'm going to have 3 times the quantity n plus 1 times x to the 3 times quantity n plus 1 minus 1, which is 3n plus 3 minus 1. That's going to be 3n plus 2. So now I check this. When n is 0, this is 3 times 1 times x to the second, which is 3x squared, which matches up with our first term that we see here. So that's my 0th term, matches my general term, and there is a power series representation for that function. All right, folks, we have reached the end of this video, the end of this lesson, the end of this unit, the end of this course. Thank you for joining me for AP Calculus BC. I hope you enjoyed the trip, and I won't see you next time because this is the last video. So good luck, everybody. I hope you have a great rest of your day, and indeed, a great rest of your time doing things. And bye-bye.